Okay, so there's quite a few questions in question 6. I just picked these ones because, yeah, I like them. Hopefully you're going to do all of them, and really only look at the video if you get stuck. But also there's a couple of tips and tricks in there, so maybe have it on the background. I don't know. Do what works for you. Okay, so again, first time we look at this, we go, right, this is substitution because it's a function times a function. Okay, and what we're trying to do is go, which is our u function, which one are we going to let be u? And in this case, we can see that sine is the one that has the power. Just written the function, we're going to let u be du by dx, du by dx, let u be sine x, and so du by dx, the derivative of that we know is cos x, and that's really great because we can see that in our thingy-bobby here. Okay, so again, hopefully you've just been doing question 5, so you're in the role, in the zone. So we can say that sine x, that's your u function, so it's u to the 4. This is your cos x is du by dx, and you're integrating with respect to x, so that ends up being, you can say you're integrating with respect to u. And we integrate, so this becomes u to the 5 over 5. Don't forget your plus c, and to finish off, we replace. So it's just to show you that nothing really changes when we've got sine and cosine. It's about finding your which one is going to be your u function, and do the same thing, look at which one has the higher power. Okay, if we have a look at C, once again we know that the derivative of sine x is cos x. Cos x is minus sine x. So because they're sort of derivatives of each other, it's hard to know which one do you let be u. But in this case, it's reasonably simple because cos x is the one that is having all the stuff done to it, okay? And it's got that power to the half. So we're going to let u equal cos x, and then the derivative we know is minus sine x. So we go about our business here. Now, one of the things, again, if you're ever stuck, the tip is separate your functions. So if I look at this, I've got 1 over root cos x times your sine x, okay, by dx. Now, what we want is we don't want sine x, we want minus sine x. So what I'm going to do is I'm going to pop a minus there, right, the minus sign, and because I've done that, I'm going to put a minus sign out the front. So a minus times a minus is a positive, and I haven't really changed anything. And what that allows me to now do is say this is minus 1 over root cos, so that's root u. This minus sine x is du by dx. As I have advised you earlier, right, try and take the time to put this extra line in, because then you are less likely to miss a negative or miss something that you shouldn't. So now we've got minus u to the minus a half. Again, watch out, because sometimes we simplify and we think that we have integrated, but we haven't really. So now this will be u to the half, divide by that half, plus c, and you can now replace your u value. So that's 2 root cos x plus c, done and dusted. Okay. Right, next one is quite common. We've just got one function, and in some cases, you know, they have a rule for this, but we're going to prove or find what the integral of tan x is. Now, to do that, you've guessed it, we have to look at sine x divided by cos x. Okay, and once again, we've got that dilemma. Which one can we make our function, or should we make our function, because one is the derivative of the other. So I'm writing this down. You probably don't have to separate it like this unless you can't see it, but quite frankly, it helps, right? So if you're unsure of which one, I mean, what's happening to the function, the most of it's happening is your u here. So I would let cos be u. If you did that the other way around, if you said u be sine x, the derivative of sine x is cos x, and then you've got 1 over, it's like that's not what we wanted, okay? So if you're ever in doubt, hopefully that will help. So just like the previous question, derivative of cos is minus sine, but we don't have a minus, so we're going to pop that minus in there, and then we have to put the minus out the front as well. Okay, so now we've got 1 over our function, which is u, that is my, okay, that's my du by dx, so that means I'm just integrating with respect to u. Because it's 1 over, that means it's minus ln of u, but my function was cos x. Okay, hopefully you did that one without having to look, and you're just checking, and that's fine. Okay, so jumped a little bit to I, but if you had skipped some of the earlier ones because you got stuck, I guess this one will help, because the trick with this again is we're not going to let u just be sine x or whatever. We're going to let it be the whole denominator. Okay, so in this case we will let u be sine 2x take 3, and we will differentiate that using our differentiation rules. Okay, and that will become, so 2 cos 2x. So follow your differentiation rules, look at your bookmark. One of the things I often do, because I'm differentiating, integrating, I make a mistake and put 1/2 there. So just, you've got to be careful, take the time to look up those rules and follow them nicely. Okay, so now what we've got here, we haven't actually got the 2 that we wanted. Okay, so you've guessed it. What are we going to do? We're going to pop that 2 in there. Okay, so we're going to put that 2, which means it's our derivative there, but in order to do that, we have to multiply by 1/2. Now I'm going to just separate that again so you can see, I guess. So we've got the half there. We've got 1 over sine 2x take 3, and then we're multiplying by 2 cos 2x, which just happens to be du by dx. Okay, so now what I'm actually integrating is 1/2 1 over my u with respect to u. So sorry to have 2 equal signs on a line here, but just save so we can have everything on the one, and 1 over u, that becomes ln of u, modulus, don't forget your modulus signs, and I can pop my function in straight away, 2x take 3, and don't forget the plus c. Okay, on to the last 3. Let's have a look at this one. Yep, so have a look. If you want to let u be sine x squared, you could try it, but then you get stuck because you go, what is the derivative of sine x squared? That's going to be using your differentiation rules, right? That's going to be 2, I'm looking at now, what does it be? Cos x. So cos x squared times the derivative of that, and that's not what we've got here. So that means you have to go lower. You go, well, you can't make it be the whole sine x squared. What if we just let u be x squared? So then du by dx is 2x, and that looks like it's something that we can fool around with here. So I can now, I better write that again actually. So what we can do is we've got that x sine x squared by dx, but what we want it to be is we want that to be the 2. So like we have done before, if we times by 2, all we have to do is times by 1/2, and then we're good to go. So now what I've got is I've got my integral of sine x squared, but that's actually sine of u, and then the 2x is my du by dx, integrating with respect to x, so they cancel. And so what I'm actually doing is I'm integrating sine u with respect to u. So I can go straight to my integration rules, and the integral of sine u is minus cos u, so that will be cos of u, and what is my u? It's x squared plus c. Done. So don't be afraid, right? Write down, you thought it might have been sine x squared, try it. If it doesn't work, see, look for the smaller function and go, well, what would I have to differentiate to get that? Okay, onward. Okay, so let's have a look at this one. You sort of go, like we did before, if we tried to do cos x to the power of 5, yep, that's not going to give me sine x cubed. So there's a bit of an issue there. So at this one, we have to think a little bit outside the box and go, well, how could we possibly separate it to help out? And we're thinking sine and cos, whatever. So what if this might not be something that you think of first time, but once we've done it once, then hopefully it's in your tool belt of things to go. Now, why do you think I've done this? Because I can get tan cubed from that, and what I'd be left with, so I've got sine cubed upstairs, but cos to the 5 downstairs, so I'd have to times that by cos squared x. So it might still be a little bit unclear and go, why are we doing this? Well, 1 over cos squared is actually sec squared x. Okay, and don't had a bit of a pause there, sorry. So that one there is sec squared x, and sine cubed over cos cubed we know is tan cubed x. I don't know why I switched those over, but anyway, oops, getting a bit excited. And I guess this is where we want to go back and have a look at your derivative rules, right? Because we know that if y equals tan x, the derivative of tan x is sec squared x. So what do you think we'll do, and what are we going to let u be? Well, hopefully you have said u will be tan x, because from above, du by dx will then be sec squared x. Okay, so now I'm integrating u cubed. That's my du by dx, so I'm integrating that with respect to u. And I think you can take it from here. So it's u to the 4 over 4 plus c, and we just replace that. So it's going to be, we can write tan to the 4 over 4, or we can say it's 1/4 times tan to the 4x, however you want. Just running out of room, plus c. Bang. Okay, one more. Okay, we look at this, we go, yeah, no worries, but we haven't got two functions. Then we go, well, let's just go back to our rules. Can we just integrate this? Well, no, we can't. We haven't got an integral rule for that, one that we can use anyway. So we have to have two functions, I guess, try and separate. And one of the things, well, the only thing at the moment that we could do is we could separate this, and we know that cos cubed would be cos x times cos squared x. And hopefully in the back of your mind, you're going, well, if I've got a cos, if I want to use my substitution rules, then I need a sine somewhere. Now, as soon as we've written cos squared x, hopefully we're all jumping up for joy, because we have our beautiful identity that sine squared x plus cos squared x equals 1. So that means I can rearrange this, and we can have that this would then be cos x multiplied by 1 minus sine squared x by dx. Okay, now again, think about which one you're going to let u be, and you might go, well, what if we let u be 1 minus sine squared x? Now, when you differentiate that, well, the derivative of 1 is just 0, so that's good. But what is the derivative of sine squared x? It's not just cos x. So that means maybe we should go a little bit smaller in our u statement. So what if we just said, let u be sine x? Okay, so now the derivative of sine x, hello, don't you just love it? The derivative of sine x is indeed just our cos x, which we have there. So when we rewrite this now, instead of 1 take sine squared, it's going to be, I don't need all of that, do I? Well, I'll put it in the brackets because I've written it. It's 1 minus u squared. Cos x is my du by dx, integrating with respect to x. So now I'm integrating with respect to u. And I can just integrate one term at a time. So the integral of 1 with respect to u would be u minus u cubed over 3 plus c, and now we replace our u. So that would be, it's sine x minus sine cubed x over 3 plus c. Okay, so hopefully that's helped you out a little bit. Go back, practice some. There's more in the review sets, and I'll put some more up on OneNote.